Okay, so for this particular question, it wants us to find the derivative, so we'll do that first. Y dash is 2x plus 7. Then it wants us to complete the table. That's this table here. So I'm going to put in minus 4 into here. So I get minus 8 plus 1 is minus 1. That's a negative. Minus 7 over 2, well, that becomes minus 7 plus 7 is 0. So we've got a flat spot. And then minus 3, so we've got minus 6 plus 1 is positive 1. So going down, flat, and then up. So to determine the nature, what we would say is it is a stationary point at x equals minus 7 over 2 as the derivative is 0. And more so, we would say that it is a minimum turning point because it changes gradient from one place to the other. Now we're going to put all that information into a sketch. We've factorised it down here so I can see that I've got at minus 1 and at minus 6 I've got roots. At minus 7 over 2, which is minus 3.5, is where I'm going to have my minimum point. When x is 0, my y-intercept is going to be up here at 6. My actual stationary point at minus 3.5, so I need to put that into here, so I might work that out over here. The function evaluated at minus 7 over 2 is going to be minus 7 over 2 squared plus 7 times 7 over 2 plus 6. That's 49 quarters plus 49 halves plus 6. And that is minus 6 1/4. So this is the point here. That is our minimum where it was bottoming out. See a negative gradient on this side passing through here, and a positive gradient on this side passing through here and through my intercept as well. Next question, find the derivative. So our derivative is going to be minus 1 minus 2x. Complete this table now. So when x is minus 1, I'll set this out so you can see. I'm evaluating y of minus 1. I've got minus 1 minus 2 times minus 1. So there's lots of negatives here. So make sure you mind your signs. Minus 1 plus 2 is 1, positive. We've also got y dash of minus 1/2. Well, that means we've got minus 1 minus 2 times minus 1/2. 2 times 1/2 is 1. Minus times a minus is a plus. So I've got a plus 1 here. Minus 1 plus 1 is 0. The last point to work out is when x is 0, and that's easy. We can see that's going to be minus 1. So we get 0 and then negative. So that's what we're looking at. Now we want to determine the nature. Well, we can determine the nature by interpreting this table. We can say that at x equals minus 1/2 we definitely have a stationary point because the derivative is equal to 0. In fact, we can say that at x equals to minus 1/2 it is a maximum turning point. It's a turning point because it's changing from one to the other, and we've got this maximum shape that we can see here. So that's the nature. We need to now sketch this as best we can. You can see that I've factorised it down here, so I'm going to have a root here at minus 3. I'm also going to have a root here where x equals to 2. At halfway, which was our minus 1/2 point, there's our turning point. And now I need to just check the y-intercept. When x is 0, we're going all the way up here to 6. And we know it's a maximum, so our maximum point is going to be above that point there. We'll just check where that is. Y minus 1/2, we'll know what the actual maximum value is. We've got 6 minus the half minus 1/2 squared. Again, be really careful of your negatives. 6 plus 1/2 minus 1/4. What we have here is 6 1/4. it's just a little bit above that point. Now putting all that together, we curl up here, through there, down, through there. And that is our function.